Welcome to Get Your FRQ On. This question is from 2018. It is question 6 and it is not calculator active. In the question stem, we have a differential equation of the form dy dx equals expression. And in part A of this question, we are asked to sketch the solution curves that pass through the point 0, 2 and the solution curve that passes through the point 1, 0. It's important to understand here that this is asking for two different solution curves. It is not asking for one solution curve that happens to pass through both of those points. If you look at the slope field, it would be nearly impossible to draw one that would do that and actually make sense with the given slope field. So this is going to be two different curves. All right, and the first one, if you look at the equation for dy dx, which is 1/3 x times y minus 2 squared, if it goes through the point 0, 2, and y is equal to 2, well, 2 minus 2 is 0, 0 squared is 0, 0 times 1/3 of x is 0. So the slope at 0, 2 is 0, and if I move over a little bit in that direction, I'm going to get another point whose y-coordinate is 2, and dy dx will be 0 again, and so we end up with this sort of horizontal line as the particular solution that goes through 0, 2. Right, and then the other one is supposed to go through 1, 0, which you can see right here. And if I follow the slope field for that point, I would get something that looks like this. All right, notice that that is not a horizontal line. In part B of this question, we are given that f of 1 is equal to 0. And to use that information to write the equation for the tangent line to f at 1, 0 and use it to approximate f of 0.7. All right, well, in order to write the equation for the tangent line, I need its slope, so I'm going to evaluate dy dx at the point 1, 0, which turns out to be 4/3. And since I know this line has to go through 1, 0, I can write the equation in point slope form, which y is 0, so it's just going to be y equals 4/3 of x minus 1. And now if I want to use that to approximate f of 0.7, I can just replace y with f of 0.7 and x with 0.7. And if I do that and do the arithmetic here, I get f of 0.7 should be about -2/5. In part C of the question, if we use the initial condition that f of 1 is equal to 0, we are to find f of x. This is an AB course. The only real method we have for solving differential equations like this in AB is to use separation of variables, which is the expectation here. In fact, oftentimes in the scoring guidelines for questions like this, if you don't use separation of variables, the penalty can be severe. Oftentimes you will fail to earn any points. So when it looks like you would use separation of variables, make sure you use separation of variables. All right, so I have dy dx equals 1/3 of x times y minus 2 squared. All right, separating the variables, we get dy over y minus 2 squared equals 1/3 of x dx. Integrate both sides. And we get -1 over y minus 2 equals 1/6 of x squared plus c. All right, now use the initial condition 1, 0 to solve for c. Do the arithmetic, we get c equals 1/3. And then substituting the 1/3 back into our solution, -1 over y minus 2 equals 1/6 of x squared plus a third. Solving all of that for y, we get y equals -1 over 1/6 of x squared plus a third plus 2. Don't necessarily have to have it written this way, but you do have to have something that's equivalent to that.